Good afternoon, folks. So what we're going to be doing today is a road geometry question from the 2011 ordinary level paper. As always, this comes up in the section C sections, okay, and it is usually the first question as well. So 2011 ordinary level road geometry. So what we'll do is we'll start off by reading the information and then we'll kind of look at doing the question here. So it says, the accompanying map shows ground contours at 5 meter vertical intervals. Part A. On the drawing supplied, draw a vertical section profile along the line AB. So you can see we have a line AB here, which is basically a vertical section being cut through, obviously, our topography here, our land. And what we have to do is draw that profile of where it intersects the land or cuts the land. Part B. The valley to the right of point A, okay, so we've got a valley here, so I'd imagine the land is going down, floods during heavy rain. Draw a line on the profile to indicate the surface of the water when it is 8 meters in depth, okay. And then CD is the centre line of a proposed roadway which is level at an altitude of 25 metres. So C to D is a roadway that has a height of 25 metres. Using side slopes of 1 and 1 for cuts, complete the earthworks on the northern side of the road, okay? And obviously the southern side they've already been done. You can see it kind of down here, okay? So we'll start off with part A there, and we have to do a vertical section profile along the line AB. So first of all, as always, we're going to work out our scale. So the distance between our contours is 5 meters, guys. So, and our scale is 1:2000. So what I will always do is in the empty space somewhere on the sheet, okay. So 1 millimeter on our sheet equates out to 1,000 millimeters in reality. So I say OS for on the sheet, IR for in reality, okay. And what we have to work up to is, we know 1,000 millimeters. Okay, I'll just put in mm there, is equal to 1 meter. Now the distance between our contours is 5, so we have to get up to 5 meters. So what do I multiply 1,000 millimeters to make 5 meters? I multiply it by 5. So it's right in times 5 there. So that'll be 5,000 millimeters, which we know is 5 meters. So 5,000 millimeters in reality, if I multiply this by 5, I also multiply whatever scale is on my sheet. So 5 times 1 is 5. Okay, so that's kind of the magic number we're going to use there. It's 5. So 5 millimeters on our sheet equates to 5 meters in reality. Okay, so that's the distances I'm going to step up. So the next thing I'm going to do is I'm actually going to look at my contours, guys. So I'm going to see here I have a 40, I have a 35, I have a 30, and I have to look at what's passing through this vertical section profile AB. So it's going as far as B here, and if I follow B down, I can see it's 55 down here. Okay, at this point it's 60, 60, 55, this one's 50, 45, 40, let's make sure, yeah, 35 I assume, 30, 25 and so on, okay. So what I actually have to do is look at my lowest one, and I think my lowest is 25 and my highest is 60. So what I would usually do then in that case, if my lowest is 25, at the side here in the space, because this is where we're going to do the profile, I'm going to start with 20 right there, and I'm going to measure up in 5 millimeter increments, okay, and every 5 millimeters equates to 5 meters. So that'll be 25, 30, 35, 40, 45, 50, 55, I have to go one more, 60. That's what I want. So I'll put in the heights there, 25, 30, 35, 40, 45, 50, 55 and 60. Okay, so there's all the heights put in. Now I'll draw in those lines going horizontally across. What I would usually do as well is, rather than having them going the whole way across, he is at a height of 55, so I know it's going up quite high, and that's my last one, just so I have a little guide there of how I have to roughly draw my lines in, or how far I have to draw my contour heights. So that's the 30, 35, 40, okay, so that's all done. Now, where the vertical heights, or sorry, where the contours are intersected, okay, are cut by the vertical profile AB, I'm going to project them up. So starting with A, I know A is on the 40 contour, So I'm going to project that all the way up to the 40. Next one's at 35. Next one's at 30. 25. This one's also at 25. Now at this point, I'm just going to check down here. So it's 25, goes 30, 35, 40, 45, just so I know. So it goes, just making sure, 30, 35, 40. This one's 45. I'm going to assume the next one is 50. I'll just make sure, yeah, so it's 50 down here. If I follow it up, the next one's 55, and then we've got 60 and 60. So next one was at 50. Then I have 55. Then I've got 2 at 60 right here. It's all the way to the top. And the final one, B, is at 55. So with that done now, I'm going to just mark those points. Just so I can identify the profile of my curve. So I'll quickly sketch that in. So there we have it, guys. That is part A done. On the drawing supply, draw a vertical section profile along the line AB. Okay, so there's our profile done, and that is basically the kind of how the mountain would look if we cut through it at the line AB. Part B, the valley to the right of point A floods during heavy rain. Okay, so we can see a little valley in here, and we know that point A is right here. Point B was up here. Just put them in. Okay. And draw a line on the profile to indicate the surface of the water when it is 8 meters in depth. Okay, so that's quite easy to do. So you can see down here, this is where the valley starts, right down here. Now, even though this point here was at 25 and this point here was at 25, it's not the valley. As it's going down, obviously you'd assume that it's going to dip a little bit below 25 before it comes back up, because that was the direction of the land, okay, as it was going down before it comes back up. Likewise up here where we had a point at 60 and 60, it's not just going to go straight across flat. It's probably going to go up, and you can see the next point after that is downwards, so it's going to go up to go down. Okay, likewise where here it's going to go down before it goes back up. So we measure 8 meters from the bottom of the valley. Okay, so just using my set square here, I'm going to measure from the bottom of the valley up 8 meters, so there's 5, 6, 7, 8. Mark it there. There's my 8. I'll do a line across. Okay, and what I have shown in that line then is how much that would flood. Okay, you'd have like a little pool of water there that would be 8 meters deep. Okay, from there. What's there? Now let's put in 8 there. Okay, so that's part B done. There's our 8 meters in. Okay, now what we have to do is the last part. CD is the centre line of a proposed roadway which is level at an altitude of 25 meters. Okay, so C to D is level at 25 meters. Now, if we look at the actual road itself, okay, the bottom side, the southern side of the road is done, the northern side isn't. But the road itself seems to be a lot lower if we look at the topography around the land, 25, 30, 35, 40. The land all around the road is bigger than the road's height, okay? That means because it's higher than the road, we're going to be doing cuts, okay? And they've given us a cut ratio. So using side slopes of 1 in 1 for our cuts, complete the artworks. So because our cut ratio, so go back up here, our cut ratio is 1:1. We'll kind of refer back to our kind of magic number here of 5, okay? We're just going to times that 1 by 5. So 1 millimeter on our sheet is equal to 1 millimeter in reality, or 1 meter in reality. So this is millimeters on the sheet, meters in reality. Okay, so OSIR again. So that basically means we're moving 5. Okay, I actually mixed that up there, guys. Sorry about that. So essentially what that means is it's our cut triangle. Sorry about that. For every 1 meter we travel up in vertical height, we also travel out 1 meter from the side of the road. So we multiply that by 5. Sorry. So for the 5 meters we travel up to cut away from the land, we're also going to travel out 5 meters from the road. Okay, so we're still getting the answer of 5. Alright. Now, first of all, what I would identify is there any parts of the road where the contours are at 25? That's where the land is going to be the same height as the road. I can see I have a contour here which is 25. Okay, same concept as we did up here. We're going to put in kind of our contours measuring out from the side of the road. So just looking here, is there anywhere else where it's 25? Nope. So what I'm going to do is I'm going to have to go all the way to 60 here actually, and I'm going to put in my measurements. So at the side of the road here we have 25. It's different from my profiles up here where I started at 20. I'm going to measure up in 5 millimeter increments of 5 meters, 25, 30, 35, 40, 45, 50, 55, and finally 60. Okay, so same concept. I'll write in these as I'm going along. So 30, 35, 40, 50, 55, and finally 60. So this is what I'm going to do. So for the 31 here, I will project it across. Same with the 35. Might need to go the whole way, but on your sheet you'll be using a pencil, so this will appear a lot lighter and neater. Okay, so you can see my contours are going across there. So now it's just a case of identifying where those kind of cut points are. So we had one at 25 here. Now we can see the next one is at 30, so follow the contour up. So there's 30. Next one's at 35. See, this one's at 40. 45. Next one's at 50. Then we have 55. 60 here and 60 here. Then we have 55 here, going back down, 50, 45, 40, 35, 30, so it's getting closer to the road. Got 30 here again, then we're going back away from the road, 35, 40. I forgot to actually bring that line over a little bit further. Actually, I just have one more, 45 there. So once again, I'm just going to speed up the video on that a little bit. Right folks, so that is the last part of that one done. What we have done is we have completed the earthworks necessary on the northern side of the road. And as you'll see there as well, I put in these guys here, okay? They're known as tadpoles, okay? And the only reason they're called tadpoles is because essentially it's like a round head, okay, with a little tail. Kind of looks like a tadpole, but the idea behind it is they identify whether you do a cut or a fill, okay? And the reason this identifies that it's a cut is because the land around the road is higher than the road. So if you imagine we put a ball on top of that, the ball will roll down the hill towards the road. When it's a fill, the road is higher, okay, than the land, so the ball would start here and roll away from the road, okay? That's the way we do it there. So that's the 2011 order level question, guys. Hope you found that helpful. That is the video done.